So good morning, everybody. Our next session of the day, so this is a miscellaneous section. We just had a really interesting talk about things that are very on the user front-end UI facing, and now we're going to pivot a little bit deeper into the stack to have a talk on Jupyter Server, and David Brochart is going to give us that presentation. So we can see your screen, so whenever you're ready, take it away, my friend.
I am ready. All right. Hello, everybody. I hope you are having a great JupyterCon. I'm David Brochart. I currently work at QuantStack. Zach Saylor was supposed to come here, but unfortunately couldn't. He works at Apple, and he lives in California. So I'm going to talk about Jupyter Server, the workhorse that drives nearly all Jupyter web applications. Let's first start with this simple question. Maybe you're wondering what you're doing here. Do you even use Jupyter Server? You just want to use Jupyter Lab. So let's see. When you use IPython, do you use Jupyter Server? Yes, no? No, that's the right question. IPython is just a wrapper around Python, but no server involved. What about Jupyter Console? No, Jupyter Console is just IPython, but with the kernel abstraction, so that you can use more than the Python language. What about Jupyter Qt Console? No, Qt Console is just gives you richer representations, so it doesn't work only in the terminal. You can have plots and so on. What about Spider? Still no. Spider is a full desktop application, no server involved. Jupyter Notebook? Yeah, this one, yeah. It's a web application. It needs a server. Jupyter Lab? Yes. Also yes. Jupyter Desktop? Yes, Jupyter Desktop is an Electron application, but under the hood, it uses Jupyter Lab and Jupyter Server. Jupyter Lite, that's a trick. I'll let you meditate on this one. So what is Jupyter Server? It's the official web server used for most Jupyter web applications. As we said, Jupyter Lab, Notebook, voila. Unless they run entirely in the browser, so that answers the question of Jupyter Lite. Jupyter Lite doesn't have a real server. It mocks a server. It's also the backend that serves that's the backend service that makes remote access possible if you want to deploy your application. For example, Binder uses Jupyter Server, Jupyter Hub, of course, Pangeo. Where does it fit in the Jupyter ecosystem? Well, it's here. We currently have these servers. So Jupyter Server is the official one. JupyterVerse, I'll talk about that in a minute, is a new Jupyter Server. And Jupyter Hub launches Jupyter servers. And the applications I mentioned earlier are here. Notebook, voila, Jupyter Lab. I'm not going to talk about the rest. There was already a talk about that yesterday. All right, demo time. So I pre-recorded it. Okay, I have an environment. I install Jupyter Server. Micro is super fast. What does happen when I launch Jupyter Server? I get a URL with a token for security. I open it in a browser, and just says a Jupyter server is running. So that's a good sign. Jupyter Server extension list. So we can see that there is one extension. It's the terminals extension. That's because for security reasons, terminals were extracted out of core Jupyter Server so that people can have the choice to not even install it and not have a vulnerability of executing arbitrary code on the host. All right, what happens when I install Jupyter Lab? Well, Jupyter Lab uses Jupyter Server. It's actually an extension. It's an app extension. So now if I list the extensions, I have many more extensions. Jupyter Server File ID, terminals again, Jupyter YDoc for collaboration, Jupyter Lab, NB Classic. And what happens if I launch Jupyter Lab, copy that in a browser? You saw that I enabled the terminal extension, so it's here. Jupyter Lab detects that, and I can open a terminal. If I want to disable terminals, I can do that on the command line. Disable Jupyter Server terminals. If I list my extensions, I can see that terminals is disabled. And if I launch Jupyter Lab again, well, now Jupyter Lab is smart enough to see that there is no possibility to launch kernels. Okay, so that works great. I can re-enable them through the command line, for example, or even through configuration files. But here I'm showing how to enable terminal extension through the command line, and that will overwrite the previous steps where we disabled them. And terminals are back again. So several ways of managing extensions, command line, configuration files. Now I want to show how we can build an extension to the Jupyter Server, because that's one of the main functionalities of Jupyter Server, is that you can add your own endpoints. So you have to have this function declaring the path to your handlers here. It means that in this module, my paths are located there, and my server extension handlers, this is this file. Let's go in and look into handlers. My handler is declared in this function. That's the endpoint path, and that's the class, the Tornado class, to my get endpoint. In this case, I'm just printing the hello world message, and it's authenticated. It means that if I don't pass the token, I won't be able to access that endpoint. Then, in order to publish this extension and make it visible to Jupyter Lab, I need to write and copy this file in the right place. It means that server app extensions, the name of my extension is true. It means it's enabled. If I want to disable it, I would just write false. Then in my Pi project, I just need to say that we want to copy whatever was in Jupyter config, the previous file, to this path of my installation. Now let's pip install this extension. And let's see if we can access it. So we copy the URL again. Okay, that's the root URL, but let's go to the URL we defined, my extension hello. Hello world. So it's simple as that. I encourage everybody to try and make your own extension. By the way, this repo is available on GitHub. So let's talk a bit about security, because when you have a server, you have to think about security and who can access it. So, for example, if I'm alone working on my machine on a local setup, I may just want to disable everything. That's doable. If I don't want any token, I can pass it on the CLI and no password either. And then I can access my Jupyter Lab application without any token on any browser. But if you want to target multiple users, then you might want to, and you want to restrict access. So by default, Jupyter Server comes with a token authentication mechanism. That means that you will pass it you will open a tab and pass the token like that. And that's a cookie authentication mechanism. So the server is going to put a cookie on your browser so that when you open this URL again, you don't have to pass the token anymore. So extensions, we talked about it. These are Tornado extensions because Jupyter Server is based on Tornado. There are two extensions mechanisms. One is for adding endpoints, just like I showed. For example, the resource usage extension is the popular extension for monitoring memory and CPU usage on the server. Or you can create a whole new Tornado application, and that's, for example, the case of Jupyter Lab. Jupyter Lab is a complex application, so it's a whole new Tornado application. And then you have to make your extension discoverable through files, as I showed earlier. You can also customize Jupyter Server. So Jupyter Server is manager-based. For instance, the contents manager is the manager responsible for accessing files. So it's an async one. And the contents manager that is shipped by default in Jupyter Server manages your local file system. But you may want to implement another one that, for example, targets an AWS S3 buckets on the cloud. Then you will have to create such a customization and have a client in your contents manager that sends requests to AWS. So once you've done that, you can override the contents manager class configuration in Jupyter Server, and you should be good to go if it respects the same API. One of the things that are coming to Jupyter Server is real-time collaboration. So maybe you followed the Jupyter Lab talks that we had yesterday and the day before. Jupyter Lab is getting collaborative, so Jupyter Server has to provide some service for that. We have a WebSocket endpoint for rooms. A room is a place where collaborators share a document and a document view. So multiple users connected to this endpoint will see document changes live. And this works hand in hand with the Jupyter File ID service, which is responsible for tracking file operations like renaming and so on. This is all backed by the YPy library, CRDT, that is the counterpart of the YJS library that runs in the browser, but it uses the same protocol. And it is kind of replacing the contents API, because now most of the content of your files are transmitted through this WebSocket instead of the REST API that we had in non-collaborative mode. What's new in Jupyter Server 2? Jupyter Server 2 was released end of last year. So because we are supporting collaboration, we need to have some support for authorization also. Previously, Jupyter Server had only support for authentication, but this is really a binary thing. Either you can access an endpoint or not. But now we need to have finer grain on that. Like you may want to give only read permissions to someone for them to read a notebook, but not execute it, for example. So That's what the authorization allows you to do. For that, we have an identity provider, which is a GET request at /API/me. So Jupyter Lab, for example, will ask the server, who am I, through this API, and it will get back user information, like the name and so on, and also the permissions that this user has, so that Jupyter Lab can adapt the UI accordingly and, for example, doesn't even show the possibility to execute a notebook. So with this mechanism, we can restrict access depending on rights and roles that users will have. So we might be able to read a resource, write a resource, or execute it. In Jupyter Server 2, we also have a new event system that broadcasts anything relevant that can happen on the server to the front end, so that Jupyter Lab can show you UI notifications, for example, when a file is renamed, when someone logs in, when anything that can happen. Jupyter Lab can subscribe to these events and, yeah, as I said, show UI notifications. What's the future for Jupyter Server? Right now, Jupyter Server is kind of a monolith, except for the terminals that we saw. Everything is integrated. The notebook is in there, but we might want to have more pluggability. Like, we are asking ourselves, should everything be a server extension? Like Jupyter Lab is just a collection of extensions. Maybe we should have the same philosophy in Jupyter Server. Like, if I just want to serve kernels, like kernel as a service, currently it's not really possible. Jupyter Server will also ship the contents API. Maybe you don't want to ship that. That would allow to compose a server as a collection of microservices, for example. This is good also for scaling. We might also want to have more explicit abstractions and schemas. Right now, we have some kind of abstraction, but it's kind of loosely defined, and it's basically in the implementation. So we are thinking about a central place, a central website that would publish the official REST API specification of Jupyter, and from this place automatically generate some code, for example, to create a server in any language, or to create code for clients also. One of the ways this could happen is through JupyterVerse. So JupyterVerse is a complete rewrite of Jupyter Server with modern technologies, especially fast API. So as I said, Jupyter Server uses Tornado, which is not an abandoned project, but let's say it's not really well maintained anymore. With the fast API comes a lot of advantages, like open API. We have automatic documentation and code generation. It respects the ASGI framework thanks to UVcorn and Starlet. It uses Pydantic, so automatic model validation and deserialization. We use fast API users, which is an extension to fast API for authentication and authorization. That opens a lot of possibilities. And on top of that, of fast API, we use a framework called Asphalt, which allows us to build a plugin framework. This is basically the equivalent of the extension mechanism that we have in Jupyter Server, but in my opinion, in a much cleaner way. So in JupyterVerse, everything is a plugin. We already adopted this philosophy. Plugins are just implementations of specifications. So there is a clear definition of what is a plugin. It's an architecture based on dependency injection, just like in fast API. that allows us to easily swap, for example, the local database that we use for users with, for example, a cloud-based solution, and we actually do that through a FIF, which is a really nice cloud-based user as a service solution. And that allows us to compose a server as a collection of microservices, as I mentioned earlier. So, for example, we can use Nginx to really build a production-ready solution. We are also thinking about experiments like, could we do server-side rendering? JupyterLab is a really complex application running in the browser. It's great. I really love it. But with that comes also a lot of complexity. So it consumes a JSON API, and there is a whole complete program application that runs in the browser. So it means like you have two states, one in the server and one in the client. Also, JupyterLab talks the kernel protocol. This is a really low-level protocol over WebSockets. This comes with a lot of complexity as well. But we could imagine the web client being a simple renderer. There are technologies to do that, for example, HTMX, that allows us to render fragments of HTML, or textual, that basically renders characters. JupyterVerse has a post-execute REST API where the front end just asks to run cell number I of the notebook and lets the server do the job, and so that it doesn't talk the kernel protocol. So that's a way to avoid a lot of complexity. Yeah, so that's basically it. How could you get involved in Jupyter Server? Well, this is the GitHub repo. There is a server and kernels meetings every Thursday. Everyone is welcome. We discuss issues, pull requests. We do brainstorming. And it is followed by a contributing hours, just after the meeting. So that's a time where we do hands-on training, onboarding, ask me anything. So really don't hesitate. It's handled by Zach, who is very friendly, very welcoming, very helpful. So he's not here today, but if he were, he would probably say that. That's his famous quote, so I'll end this presentation with this quote. Thanks a lot.
Thanks very much for that review and dive into Jupyter Server and some related technologies. Questions from the audience? Hand shoot up right away. Love it.
Thank you. So thank you for this great presentation and for the great future for the Jupyter Server. So I have basically two questions. So the first one, it's regarding the collaborative mode. So authorization, you mean that now providing the users and distinguishing the users, is this context provided also? So maybe some background. In the notebook server, and I think in Jupyter Server 1, so there is a handlers between the managers and the browser, so like contents handler. And when you are making authorization, so there is returned true or false, and the context, for example, from user is not provided to the manager. So if I want to go to some S3 API, I need to provide something like environment variables. Is it somehow planned to solve, or is it already maybe solved?
That's a very good point. We talked about that not so long ago. We have some ideas to do that. Actually, Zach experimented with that already. And it's probably going through the use of async context variables that we that any handler will have access to through the request, and we are going to specify the format, the schema of these context variables. So yeah, this is an ongoing work, but this is going to be possible soon. In JupyterVerse, I think we will have another approach because we will take advantage of dependency injection. So yeah. This is the fast API philosophy, and I think we are going to stick with that.
Okay, thank you. And the second question, you mentioned about the Jupyter Server, about making it like as a plugins. So, but there is currently also the kernel gateway server that exists that allows to connect to the remote kernels. And basically, it's I think it's like Jupyter Server, but without contents API endpoints and other notebook-related stuff, only for the kernels and sessions. Will it be also be part of the Jupyter Server, or it will be somehow deprecated, or what's the future of it?
I'm not sure it's really at the Jupyter Server level. It is also a limitation of Jupyter Lab, which accesses a range of kernels, a flat list of kernels through the kernel specs. And this part is also going to change because we are going to bring more hierarchy into that. Like I want to access this cluster that offers me this set of kernels and it's located somewhere else. And then through Jupyter Lab, we will probably have the ability to target local kernels, remote kernels. I'm not sure it's going to follow the gateway API. We need to discuss that, but yeah, that's going to be possible. For sure, we are going to take inspiration from what has been done already.
Okay, thank you. Thank you.
You're welcome. More questions?
I'm not seeing any questions, so, oh, hold on.
What can we expect in terms of timeline for the future that you talked about with JupyterVerse and future deprecation or retirement of Jupyter Server or anything like that?
So currently, Jupyter Server is still the official server. One of the reasons is there are so many extensions out there that don't work out of the box in JupyterVerse because Tornado and FastAPI are very different frameworks. It's not very difficult to rewrite them to JupyterVerse, but that would be left to the extension authors to do that. And also, I mean, time will tell. We can't. There is no will for JupyterVerse to replace Jupyter Server. I think both solutions could live in parallel. But I have the feeling that if we stick with Tornado, it's basically an end. There is no alternative to that because it's not a maintained framework. FastAPI is just so popular, so trendy. Everybody's going there. So, and I think it has a lot of potential. The author of FastAPI is going to work full-time on it this year, so I expect a lot of progress there also.
Well, thanks very much, David. We'll wrap this up.
Thank you.